Good day, everyone. This presentation will be on the topic Heat Recovery Steam Generator, in short, HRSG. Let's get started. So, HRSG, a heat recovery steam generator, is an essential component in combined cycle power plant and industrial processes where it recovers waste from exhaust gases of gas turbines or other high temperature sources to generate steam. We'll explore their working principles, advantages, shedding light on their crucial role in maximizing energy efficiency and minimizing environmental impact. Now, types of HRSG configuration: horizontal gas flow, vertical tube, natural circulation design. So this figure here shows the horizontal tube evaporator. The steam enters from the left. So let's get started. It is by far the most common design utilized in today's market. This design uses the natural buoyant forces of the steam or water mixture in the vertical evaporator tubes to circulate the mixture. Gas enters the HRSG on the left, flows flows across the vertical tube where steam is generated. So it requires a minimum amount of control and is easy to operate. So the steam enters from the left, enters this vertical tubes where steam is generated. Vertical gas flow, horizontal tube circulation design. It is used in the early days of combined cycle development. This design requires pumps to circulate the water-steam mixture through the tubes to the steam drum. Gas enters into the left from the left, turns upward, and flows over the horizontal tube where the steam is generated. Steam enters, flows over these tubes where the steam is generated. HRSG working principle or the operation of HRSG. HRSGs utilize the waste heat from exhaust gases. So we are talking about the exhaust gas recovery, typically from gas turbines to generate steam. These gases, still containing significant thermal energy, pass through the HRSG, transferring their heat to water or working fluid. This diagram or a figure here showing, so we have a compressor, natural gas, this is a combustion chamber, turbine, hot exhaust gas into the gas duct burner, then into our HRSG, then transferring their heat to a water working fluid. So this shows it right here. Now, steam generation. As the heat from exhaust gas is transferred, the water within the HRSG is heated. The water undergoes a phase change, transitioning from liquid to vapor, producing steam. This steam is then utilized for various purposes. So the figure on our right here shows that. So as you can see, we have a boiler here. We have our streamline, our turbine, our generator, our transmission lines. We have our water supply and our cool supply. We have our vapor here. HRSG advantages and applications. One advantage of HRSG is its increased efficiency. HRSG significantly improve overall energy efficiency by recovering waste heat, which would otherwise be lost. This translates to lower fuel consumption and reduced operating costs. 2. reduce emissions. By utilizing waste heat, HRSGs minimize reliance on fossil fuels, contributing to reduced greenhouse gas emissions and a more sustainable power generation process. Diverse applications. HRSGs find wide application in various industries, including power generation, oil and gas, chemical processing, and district heating. They contribute to energy efficiency and sustainability across diverse sectors. Now, let's look at the application of thermodynamic theory in HRSG operation. So first law of thermodynamics, which is also known as the energy conservation law. The first law states that energy cannot be created or destroyed, only transformed from one form to another. Heat transfer from exhaust gas. So we have an equation here. We have heat energy in, that is the heat energy transferred from exhaust gas to water or steam in, equals the mass flow of the exhaust gas multiplied by the specific heat capacity of exhaust gas at constant temperature times the change in temperature. So temperature in minus temperature out. This diagram shows exhaust gas heat exchanger. So we have the exhaust gas inlet, the primary circuit, the secondary circuit outlet, the pressure relief valve, the secondary circuit inlet, the primary circuit, and the exhaust gas outlet. So heat absorbed by the water or steam equals Q out equals M substrate W S dot H in minus H out, where MWS represent the mass flow of the water or stream, and then H represents the specific enthalpy of the water or steam. So same, we've seen this diagram over a couple of times. We've seen our compressor, our combustion chamber, then our turbine, our gas turbine. We have our stack of flue gas here. These are our HRSG, our condenser, and our steam turbine. For an ideal system with negligible losses, our Q in equals our Q out. So, however, real HRSG experience some heat loss due to inefficiencies in heat transfers and material limitations. So, energy input. The HRSG recovers waste heat from the exhaust gases of gas turbine or other heat source. This energy is transferred to water to produce steam. So in other words, what the HRSG does is it just recovers waste heat from the exhaust gases produced from a turbine and then converts it into a water or a steam. So this shows how HRSG is very important in our chemical engineering. Energy transformation. The thermal energy from the hot exhaust gases is converted into the internal energy of the steam, thus increasing its temperature and pressure. Energy output. The steam produced is used to drive a steam turbine, which generates additional electricity. So the steam that we've been able to recover is used to drive a steam turbine, which generates additional electricity. The energy is conserved throughout the process, but it is transformed from heat to mechanical work and then to electrical work. To conclude our presentation, HRSGs are indispensable components in modern power plants and industrial processes. playing a pivotal role in enhancing energy efficiency and mitigating environmental impact. As technology advances, we can expect even more innovative designs and applications of HRSG, further optimizing their contribution to a sustainable energy future. This will end our presentation. Thank you.